This is the homework help video for power of a power property, 5-3. Okay, we're going to do all the odds together. And the rules are, if you saw the last video, the first rules we learned are if you have the same base, when I mean base, I mean the little variable or sometimes number that has an exponent. If you have the same base, you add the exponents. Okay, so that 2 plus 1 gives us 3. The coefficients, the big numbers in front, you multiply. Okay, now there's a new rule that we're learning on this paper. And that is, if you have a coefficient that is attached to parentheses, let me zoom in so you can see this a little better. See, this I said coefficient, that's wrong. I mean exponent. This exponent is not attached to a base, it's attached to the parentheses. That means it's being applied to everything inside of the parentheses. That's called a power to a power. We're not adding these, we're actually multiplying those. And if you want to write it out to understand what's happening, they're saying you have a to the power of 2 4 times. You have 4 of those guys. Now, our rule, see, these are all attached to a base of a, the same base, so we could add these, 2, 4, 6, 8. You end up with a to the power of 8. But the rule that's a shortcut for us is just multiply 2 times 4. 2 times 4 is 8. We get the a to the 8 without having to write everything out. So if you're not sure you're doing it right, you can go ahead and write it out, but learn the rule and get comfortable with it saves you a lot of time. Okay, so number 1 is a to the power of 8. Let's check out number 3. And now I want to differentiate something here, so please pay attention to this part. Now, everything in here is in parentheses, and it's all being raised to the power of 2. Okay? That means the power of 2 is being applied to everything inside. Now, this 5 is an exponent, so we're going to use the rule I just mentioned. We're going to do 5 times 2, and we're going to get p to the power of 10. However, this 3 is not an exponent, it's a coefficient. We're not going to do 3 times 2 is 6. That's not correct. Whenever you have a coefficient, that's 3 raised to the power of 2. I strongly suggest, for a good while we're getting used to this, I suggest you just do all these in the calculator. I'll show you how to put in the power. 3, to raise it to a power, you push the caret top button. It's right below your equal sign. That gives you a little template box in the exponent position. And I can put in whatever exponent I want to. In this case, I put a 2. When I push enter, I get 9. Because 3 to the power of 2 means 3 times 3, not 3 times 2. Okay? So that gives me 9. So the answer to number 3 is 9p to the 10th power. All right? Let's go on to number 5. Now this one is a little interesting because this -4 is not in the parentheses, but the 3x to the 4th is in parentheses, and it's all being raised to the power of 3. Okay, so we have to take care of that. But this -4 is not affected by this power of 3. Okay, keep that in mind. All right, sorry I get a little bit dark. I'm going to try to change that. The lights go off in the classroom and I can't help that sometimes. Okay, so basically what I suggest doing is ignore this -4 in the front because we're not using it just yet, and make a space. We're going to do our work in the parentheses and write it in here, and then we'll deal with the 4 at the end. So this power of 3 is affecting my coefficient and my exponent on my x. So I'm going to put 3 to the power of 3 in the calculator, just to do that in the calculator. 3, hold on, 3, and then caret top 3. And it looks like you'll not be able to see that because it's too bright. There we go. 3 to the power of 3. Enter, you get 27. Okay? So that 27 goes here. Now this is the rule that we just learned earlier. We're just multiplying those. 4 times 3 is 12. So you get x to the 12th. But we're not done. Now that we've taken care of this and there's no longer an exponent here on the outside, now we go back to our first rules that we learned earlier in the week. You multiply your coefficients. Negative 4 times 27. So I'm going to do negative 4 times 27, and I get negative 108. Okay, negative 108 x to the power of 12. That's your answer for that one. Let's do number 7. Number 7 looks really complicated, but it's not if you treat it as two separate problems at first. Basically, just do this side by itself and ignore the right-hand side. Okay, let's do that first. So I have everything in parentheses, b to the 4th, y to the 3rd, all raised to the power of 5. That's actually pretty easy. We learned that we multiply those exponents when one of those is outside on the parentheses. So that's going to be 4 times 5 is 20. We have b to the 20, and then y to the 15, because 3 times 5 is 15. So that's my left side all taken care of. Now I'm going to ignore the left side, do the same thing on the right side. This 3 applies here and here. 2 times 3 is 6, so we have b to the 6th power. Here we have an invisible 1. 1 times 3 is 3, so we have y to the 3rd. So I took care of the right-hand side. Now I look at everything all together. I'm multiplying this and this together. That is basically the rule we learned at the beginning of the week. The ones with the same base, you just add those exponents. So here's the same base of b. I add the 20 and the 6. I get 26. So I have b to the 26th power. And then I ignore the b, and I have y and y. 15 and 3 adds to give me 18. Y to the 18th. Okay, that's it. So that really complicated problem is basically 1, 2, 3 short problems. Okay, just chop it up into little pieces. Okay, little segments. This one's another one where you have to kind of cut it up into little sections. We have this section, and we have this section. We actually have to start with the last section because this guy has nothing on the parentheses that we need to multiply in, or actually no exponent that we have to apply inside. But this back one does. So this has to apply here and here and here. This one we're basically going to ignore. You might rewrite it or just leave it alone for now. This first one, this is not an exponent, so I don't use my exponent rule. I actually just type it in the calculator. Negative 2 caret top 3. Negative 2 caret top 3. That's what I get. And you get negative 8. So this gives me negative 8. Now this is s to the 1. 1 times 3 is 3, so now I have s to the 3rd. And this is 3 times 3 is 9, so I get v to the 9th. So now I've done the right-hand side. It's time to rewrite the left-hand side. Nothing changed, but we want to maybe rewrite it beside our other work so we can go ahead and move on. Now I get to where I multiply my big coefficient numbers. 3 times negative 8, negative 24. And then I have s to the 3rd, s to the 3rd. Those combine to give me s to the 6th because I'm adding at this point. And v to the 5th and v to the 9th gives me v to the 14th. So that's my final answer. Negative 24 s to the 6th, v to the 14th. Okay, we're moving right through these. Okay, number 11. Number 11 is interesting because this exponent of 3 on the end applies to everything inside the parentheses, but it does not apply at all to the negative 4 on the outside. So I have to ignore the negative 4 for a little bit and leave it alone until the end. This is a coefficient. It's not an exponent, so I'm not just multiplying those. I'm putting that in the calculator. Negative 3 caret top 3. Negative 3 caret top 3 gives me negative 27. All right? And then these I just multiply because they're exponents. 6 raised to the 3rd gives me x to the 18th. This 3 raised to the 3rd gives me y to the 9th. So now I've taken care of applying that exponent into all the parenthesis items. Now I can just multiply my two bigger numbers here, the ones in front. This negative 4 doesn't have anything to do with these guys. It multiplies by the 27. So negative 4 times negative 27 gives you positive 108. So I have 108, x to the 18th, y to the 9th. Okay? Now we're down to the word problems. I'm going to zoom out so we can read them. Number 13. 13 says, which best represents the area of a rectangle with a length of this and a width of this? It's pretty straightforward, actually. An area of a rectangle, it's length times width, or whichever one's length or width, this times this. So basically you're multiplying this times this. It's basically what we just did, put in a word problem. So I'm going to write out 8 m to the 3rd power inside parentheses, all raised to the 2nd power, and then it's multiplying it by 4x squared m to the 4th, all in parentheses. Now, this one does not have any exponent on the outside, but this one does. 8 to the 2nd power. Don't think it's 16. That means 8 caret top 2, or in other words, it's 8 times 8. 8 caret top 2 is 64. So we have 64, and then 3 times 2 here gives us m to the 6. Okay? Now since there's nothing to do over here, I can go ahead and multiply my 64 times my 4. I'm multiplying my big coefficient numbers. 64 times 4 gives me 256. So 256 is part of my final answer. These two have it, and these two don't, so I know I can get rid of those choices. Now, I don't have any x's over here. I do have m to the 6 and m to the 4. That gives me m to the 10. And then my x squared is in one of them, so I get x squared here. So m to the 10, x to the 2. Here it is, right there. Choice C. One more and we'll be done with the video. Number 15, which best represents the product of 3x times 4x squared times 2x squared, all carried to the power of 2? Well, we need to do this one first. 2 to the power of 2, or 2 caret top 2, that's going to give you 4. Okay, so I have 4 here. And then this, 2 times 2 gives me 4. So when I take care of this exponent on the outside of the parentheses, I end up with 4x to the 4th. So I'm going to cross out that. What I really have is 3x times 4x squared times 4x to the 4th. Let's multiply my coefficients first. 3 times 4 is 12, and 12 times 4 is 48. 12, 24, 36, 48. So I get 48. I've already eliminated two choices. They don't have 48. Okay, let's do the, and this is where you have to watch. This is 4, plus 2 is 6, but you got to remember that little invisible one, plus 1 is 7. So it's not this one, it's 48x to the 7th.